Welcome to Veteach. Today we are going to discuss about some kind of topics, subnetworking. What is subnetworking? What is super networking? How the network is divided in terms of the computer networks with respect to the network layer. So the first thing, the subnetting. In terms of the subnetting, why we go for the subnetting is the first thing. So what is the difference between subnetting and supernetting? How the network addresses are identified, how the network addresses are classified, how the network address translation is available for accessing of data. Simple. In the computer networks, it is very easy. All the systems are connected with respect to the network, which is nothing but the internet. So internet provides some kind of connectivity between the computers to share the data. So we already know how the systems are connected with respect to the server, with respect to the hub, with respect to the switch. While accessing the network, how the network is divided is the first thing. First, whenever a bigger network is divided into smaller networks, in order to maintain security, the bigger network is divided into subnetting. The first thing, to maintain proper security with respect to the systems for the transmission of the data, the bigger network is divided into smaller network. The concept is nothing but subnetting. So in this, so first, what is subnetting? For security, for smaller networks, in order to maintain the security, we are dividing the bigger network into smaller. So how we can divide? First, so here let us talk about dividing the network into two parts with respect to the domain. So first thing, divide a network into two parts. You need to choose one bit for each subnet from the host ID. So the host ID is nothing but internet protocol. So internet protocol is the representation. This is NID 193.1.2.0. So first thing, it can be divided NID 193.1.2 in terms of the representation. Next thing, this is subnet 1, this is subnet 2. So we have to choose the address from 00 to 01, here 100 to 111. Simple. The main network ID is same 193.1.2, but we are dividing the entire bigger network into two parts by assuming starting from 00 to 01, again 10 coming, the last one is the first one here. So subnet 1 end address is the starting point of the second one. So here from 0 this will be 0, here 1 it will be considered as 1. So finally the network is divided into two parts. One is said to be subnet 1 having address from range from 193.1.2 to 193.1.2 to 01 like this. Here 193.1.210 to 193.1.211 like this. So there are two cases. So it is class IP. There are 24 bits in the network ID part. 8 bits can be divided into address, 8 bits can be divided into data. So here 8 bits in the host ID part, remaining 8 bits with respect to the address of the subnet. Coming to for subnet, the first bit how we can divide, the first bit which is chosen from the host ID part is 0. Already I explained, host ID part is 0 and the range will be from like this, host ID, till you get all ones in the host ID part. For example, in this case 193.1.2 host ID is 000, 1 2 3 4 5 6 7 8, 8 bits, to host ID all ones comes 0 to 111, 1111, 7 ones with respect to 0, except for the first bit which is chosen 0 for the subnet ID. So the ID is divided from 00000 to 111 except the host ID which is the address of the major network, bigger network with respect to subnet with reference to host ID. Coming to the range can be from 1.0 to 1.127, total 128 bits. Total 128 bits. Coming to subnet 2, the same thing. The host ID part is 1 and the range will be from, this is the host ID part, coming from 2 1 0 0 0 0 0 0 0 to 1. These all changes into with respect to 7 ones. The same thing, the first part itself consists of host ID, the remaining 0 to 1. 0 to 1 in the sense starting from 0 to 127. 1, 1, 1, 1, 1, 1, 1. Total 7, 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7, like this. Starting from 0 to 7, because these all are binary. So we can divide with respect to 2 power 0 to 2 power 7, that is 127. 127. Again the third thing, the third one, if it is subnet 3, the same process. The host ID is the first bit, again from 0000 to again from 111. This is the concept of subnetting. Coming to supernet, the same concept, opposite, smaller network into bigger. In subnetting, a single big network is divided into multiple smaller networks. In supernetting, multiple networks are combined together to form a bigger network. In subnetting, what the basic procedure? Dividing the bigger network with respect to the small one for the purpose of security. How the basic procedure? It consists of host ID, the first thing, again from 0 to 127, total number of bits. Coming to supernetting, here the procedure is entirely different with respect to the subnetting. Here we combine some kinds of small nettings to form bigger. Multiple networks are combined into bigger network termed as super network or supernet. So here supernet is mainly used for route summarization, finding the path to all the nodes who are connected entirely, where routes to multiple networks with similar network prefixes are combined into single routing entry. Easy to find out the path with routing entry pointing a super network. In this supernetting, it is very easy to transmit the data all the network to find out the routing, which one is the best one. But coming to subnet, each and every time the IP address may be differ with respect to each other. So, but in terms of the supernetting, it is not possible to find out each and every time, because all the networks are internally connected. So it is very easy to find out the routing. So when multiple networks are combined to form a bigger network, it is termed as supernetting. Supernetting is used to route aggregation to reduce the size of the routing tables and routing table updates. So to find out the least cost thing, to find out the table each and every time, it is very easy in terms of the supernetting as compared to subnetting. There are some points. What are the advantages of supernetting? All the networks should be contiguous. All the networks are under in one kind of network control. The data may be controlled by the network. The block size of every network should be equal to, must be 2 power n. If there are 2 square, 4. If there are 3, 2 power 8, 3. So all the blocks are connected each and every time. 3 blocks, 8 connections. If there are 4, 16 connections. First network ID should be exactly divisible by the entire support. The first network ID should be exactly divisible whole by the how many number of nodes are connected. For example, 3, 8 nodes. For example, 4, 16. For example, 5, 32. For example, 6, 64 nodes are available. So in this way, the multiple networks are combined for defining the shortest path for the successful transmission of data in terms of the netting. So suppose 4 small networks of class C, how these are connected? 201.0, 201.1, 201.2, 201.3. So by combining, build a bigger network that has a single network ID. So before supernetting, how the control will be happen, who is the responsibility of the supernetting is simple. There are some conditions. First one, contiguous. You can easily see that all the networks are contiguous, having 250 hosts, 6 hosts. Second thing, range of the 0 to 200 to 255. 200.100 to 200.255. So 0 to 255 is simply said to be, size is said to be 256. Number of nodes are in the process of minimum number of nodes are 256 in the process of supernetting. If you add 1 in the last IP address of the first network, that is 200.1.0 to 255 plus 1, you will get the next network ID. So what is the size? 255 plus 1 is said to be the 1 because after 256 it comes to 0. After 256 the address will obviously comes to 0. Next thing, equal size of all the network, 2 power 8, that is 256. Each and every network consists of equal number of nodes in terms of the super networking after contiguous. Third one, the first IP address is exactly divisible by the total size. The first IP address is exactly divisible by the IP address. These are the basic procedures before going to super netting any kind of network. First one is said to be the contiguous. Number of nodes are equal, 256. Second one, equal size of the network, each consists of 0 to 256. Third one, first IP address is exactly divisible by all the number of nodes. So in this representation, how we can classify? This is 201.01. This is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. By adding we can get 200. By this one we can get 1. This is the last 10 bits of first IP address are 0. Last 10 bits of first IP address are 0. So the third condition also satisfied. Second one, control and reduce the network traffic, helpful to solve the problem lacking of IP address, because here we starting the address 200.1.0 something like this. 200.1.0 like this. This is 200 by calculating this one. So each and every time minimizes the routing table. So more number of network IDs are available in terms of the super networking. Coming to this one, minimizes the routing table, finding the number of costs will be reduced. It cannot cover a different area of the network when combined. All the network should be in the same class and all IP should be the contiguous under control of the network layer. So these are the two concepts of subnetting and supernetting. In terms of the subnetting, we can divide the bigger network into smaller one for the purpose of security with respect to the host ID. Coming to super networking, we can combine multiple networks. So first, there are some kind of conditions for super netting. How the IP addresses are divided, what are the different, what kind of connections, how many number of nodes are in each and every system. So these are the basic things while we go for the subnetting and supernetting of network layer coming under computer networks. Thank you.